A lot of times when we work with radicals, and by radicals I mean square roots or cube roots, right? We don't change them to decimals. We leave them in radical form. So we leave them as a square root or we leave them as a cube root, okay? But like fractions, there are certain radicals that we can reduce or simplify, okay? First of all, what do I mean by these two? I don't know why it does this to me every time. It does this to me every time. An entire radical is something like, I'll just give you some examples. Square root 24. Cube root 32. Square root 26. Square root 28. Cube root 54. Okay? It just means an entire radical means it's just a radical. There's nothing else with it. There's nothing after it. There's nothing before it. A mixed radical has a number before it being multiplied. So examples of this would look like this. This is 2 times the square root of 3. Or often we will just say 2 root 3 to save a little bit of time. This one here three cube root 4. Okay, so mixed means it's a mixture of a rational number and an irrational. Here, well, these are irrational numbers. So what we're going to do is how do we simplify some of these entire radicals so they look like this? That's the goal. And you have to know 2 things to do that. Okay. First of all, you have to know how to multiply radicals. Square root of 4 times 9. If you didn't know anything about how to multiply radicals, how would you do that? Square root of 4 times square root of 9. What would you do? Okay. Okay, so what's it? It's the same as? Which is? 6. There is another way you could do it, and it makes sense. The square root of 4 times the square root of 9 is the same as the square root of 4 times 9, which is square root 36, which is also 6. So there's 2 different ways you could do it. And you'll end up getting the same answer. Sometimes they're not going to be as clean as this. Like if I said the square root of 5 times the square root of 9, you wouldn't be able to do that like this. Because the square root of 5 is not an exact number. Okay? So what I want you to know is that whenever you take I'm going to put A instead of X on both sides. Whenever you take the nth root of a number and you multiply it by the same root of a different number, or it could even be the same number, that's the same as the square as the nth root of the product of those 2 numbers inside. So what I mean by that is that, as some examples, can you tell me, and remember, we're not using the calculator, the square root of 5 times the square root of 2. Don't overthink this. It's actually very easy. Square root of 10. Because it follows this rule. The cube root of 4 times the cube root of 5. The cube root of 20. The square root of 7 times the square root of 8. Don't overthink. Square root 56. Good. Okay, that's all that means. We have to know how to multiply radicals in order to simplify them. So we have to know this first. The next thing we have to know are perfect squares and perfect cubes past 1. We don't have to worry about 1. 1 is a perfect everything. It's a perfect square, it's a perfect cube, it's a perfect fourth, it's a perfect fifth. Because you can take the nth root of 1 and it's always 1. Okay? Past that, what's the next square root? Or what's the next perfect square? 2 is not a perfect square. 4 is. Then?
6. Not.
Hey, and who's she's answering?
16.
We should really know up to 100. 49, 64, 81, 100. It does keep going. Really, the only, I mean, the ones we're going to focus on are like the first 5 or 6. Now, perfect cubes past 1. What's the next perfect cube higher than 1? 4, 8. Because 2 times 2 times 2. 27 because 3 times 3 times 3. 64 because 4 times 4 times 4. One more. 125 because 5 times 5 times 5. And it keeps going, but we don't need to know the ones that. Okay, so let's practice with a few of these. Now that we know the 2 things we need. So often you will see the instructions look like this. It will give you an entire radical, square root of 27, and ask you to write it as a mixed radical. Okay? We're dealing with square roots. Remember, this does not mean, it does never mean use a calculator and round it. Never. Okay? First thing we need to do is we need to find the highest perfect square that goes into 27. What is the highest perfect square that goes into 27? 25 does not divide evenly into 27. Divides evenly into. Look at your list. What number goes into evenly? 27. 9. That means that the square root of 27 can be broken down into the square root of 9 times the square root of what? What must this number be? 3. Why did I do it that way? Because I can actually find this first one, can't I? What is the square root? I can't find this without a calculator, so I just write it beside the 3. Notice that's a mixed radical. It's a mixture of a rational number and an irrational number. And the way that we would read this, 3 root 3. Or 3 square root 3. Either one is correct. Before we move on to the examples on the next page, let's actually do another one. I believe we have this space. So let's do roots. I want to make sure let's do the square root of 24. We don't have to show all that writing and all that work that we did above. Here's how you can do it. We're going to break it down into 2 square roots that multiply together to get square root 24. No, hang on. This has to be a perfect square, the highest that goes into 24. Otherwise, you can't simplify it. What's the highest perfect square that divides evenly into 24? 4. Which means this must be, and I did that because the square root of 4 is exactly 2. The second square root I can't do without a calculator, so 2 root 6. Let's look at one more before we go to the next page. Cube root 16. This is where you've got to change your thinking. You're not thinking perfect squares now. You're thinking perfect cubes. So break it down into 2 cube roots that multiply to get cube root 16. Think of your perfect cube list. It's not very big. There's only a few numbers on it. What is the highest perfect cube that divides evenly into 16? 8. 4 is not a perfect cube. 8 is. And if this is 8, this must be 2 to get 6. 8 times 2 is 16. Why did I do that? Because I can find this exactly. What is the cube root of 8? 2. I can't do the second one, so I just write it beside. So your answer, I know it looks a little weird, 2 cube root 2. That's how we simplify these things. Okay? Let's look at a few more. Now that we've sort of warmed up with them. So remember, when you see a square root and are asked to simplify it to a mixed radical, think perfect squares. When you see a cube root and asked to simplify to a mixed radical, think perfect cubes. So when I look at this one, I'm thinking, okay, first of all, I'm going to break it up. And the first number underneath the cube root has to be the highest perfect cube that goes into 40. So you're on your perfect cube list. Which one divides evenly into 40? 8. Which means this must be, no, 5. Because cube root 8 times cube root 5 is cube root 40. Now simplify further. Cube root of 8 is exactly 2. I can't do the cube root of 5, so I leave it. And that's it. The second one I kind of threw in to make you think, we're back to square roots. So notice what I do right away before I even start doing any math, is I break it up into two square roots that are being multiplied to get root 26. Highest perfect square that goes into 26. 16 divide evenly? No. 9? Does 9 divide evenly? 4 divide evenly? So that means none. You can't simplify this one. I threw this in here on purpose because sometimes you'll get square roots, and we'll see this more in grade 11 when we start doing operations with square roots and cube roots, okay, that you can't simplify it. There is no perfect square that you can break it up and simplify it. Okay, so I just wanted to show you that as an example. This next one, though, you can. So square roots, you're on your perfect squares, not perfect cubes. You're on your perfect squares.
It's 9 to square root of
5 and 6. Yeah, which goes simplifies all the way to? No,
Oh, wait, 3 square root of 6.
3 square root 6. Good. Sometimes, oh shoot. Did I just do the third page? No, I didn't. Oh. So we did the harder ones. That's okay. Let's go back to this. Cube roots. So now you're thinking perfect cubes. Highest perfect cube that goes into 32. 8, which means that underneath the other number must be to get 32, 4. We did that because cube root 8 simplifies 2, and we can't simplify the second one. So we're done. Square roots. What are they going to be in this one? Square root 4 times square root 7, which simplifies further to 2 square root 7, 2 root 7, got it. B, we're back to cube roots. And it's a fairly big number. So you may have to use a calculator to help. Well, the highest perfect cube we had in our list was 125. No, that's not dividing evenly into, so it's got to be one of the lower ones. It's got to be 64, 27, or 8. 64? 27, check it. See if it does. Does it give you a whole number? Or does it give you a decimal? 144 divided 27.
Yeah, no.
Decimal? No. So it's gotta be. It's gotta be 8, which means this number is what? Again, you may use a calculator to help you out.
How are you getting the second? Wait, but how did you get 8?
144 divided 8,
Oh, wait.
right? Because these two have to multiply to get this. So to find the missing one, I just did 144 divided 8. Cube root of 8 becomes 2. Cube root of 18 I can't do anything with. So we're done. There are a few you got to watch out for. Like C. We're back to perfect squares. Sometimes you may get numbers that more than one perfect square goes into it. You have to find the highest. What kind of jumps, what perfect square would jump out at you right now? 4. Okay? What, I think it's 4. Oh, sorry. 40 is not a perfect square. Okay? Some of you may look at this and say, well, it's an even number, so maybe 4. And actually 4 times 20, right? But 4 is not the highest. Think about your perfect square numbers. If 4 goes into it, what other perfect square that higher may go into it? 8's not a perfect square. So try 16. See if it works. What's the other number? 5. Okay. So if you did 4, you haven't simplified it fully. That's why you've got to find the highest. So there is the occasional answer you will get, and then root 16 becomes 4, and we get 4 times root 5. Often that will happen with 4, 16, and 36. If 4 goes into it, 16 may. If 4 goes into it, 36 may. So you always want to check those ones. Okay? Are we getting a little more comfortable with this? Okay. One last thing I want to talk about. I'm all over the place. There. Okay. Before we do a problem, what happens if we're asked to go backwards? What happens if you're given the mixed radical and asked to write what was the entire radical we simplified? Well, so we have to figure out what radical did we simplify, and we got 4 root 3. 4 is the same as the square root of 16. I can multiply that by the square root of 3 to get what? Square root of 16 times 3. 48. How do you find that missing number? Four squared. That's how you can find it. You just square the number that's not under the square root. So let's just jump to C before we go back to B. What would it be? 25 is 5 squared. Which means that the whole radical would be, or the entire radical would be, square root of 15. You got to change your thinking on B. Okay, exactly. This would be the cube root of 27. Why? Because you don't square the 3, you cube it. That tells us what goes underneath. Now I can multiply those two together into a single cube root. Cube root of 54. Okay, so what kind of questions have we done? What kind of problems have we done that involve square roots? Well, one is Pythagoras. We should be familiar with Pythagoras. What is the formula for the Pythagorean theorem? Where A and B mean, what do they represent? The what? What do A and B represent on the triangle? No, I'm not asking about this one.
The length of the span. It represents. Oh, the length is.
Not quite, but you're getting closer. How do you know how to find A and B in a right triangle?
The angle. The square on the triangle. Yeah.
The square on the triangle.
But then the horizontal.
What did we call them? Do you remember? You're right. The C is the hypotenuse. That's the longest side. But what did we call A and B when we used Pythagoras? What did we call A and B? The legs. Yes. Legs. Yes. They're the two sides that make up the right triangle. You have to know this in order to substitute the numbers in correctly. Okay? So X is the hypotenuse. That's the unknown, which means we know A and B. So we're going to go 3 squared plus 6 squared equals X squared. Because those are the sides I'm given. And you guys know how to get to the answer here. So that's 45 is equal to X squared. Therefore, X is the square root of 45. Now, this is where you normally use a calculator. But if you look at the question, you are not asked to round your answer. You are asked to write your answer as a simplified radical. That must mean we will have to do the breakdown in highest perfect square. So square root 9 times square root 5, I don't even have to write the dot. Which simplifies further to 3 square root 5, and then I have my units. That's a problem. Okay? Just so we're comfortable, you don't have to write these down. I'm just going to ask you a couple of questions. Tell me how you would write this one. X squared plus 7 squared equals 8 squared. Do you agree with her? Yes, because 8's the hypotenuse. Okay. What would it be? What would the equation be? X squared plus X squared plus X squared? Ah,
But it doesn't matter in like there's
no, they can be reversed, but you have to get them right on the diagram. Because often, sometimes students will make the mistake, and I've seen this before, and I've seen this with some of you guys last year, where you would automatically take the numbers and put them as A and B. Okay, but that's not correct. You got to look at which ones are the legs, which one is the hypotenuse. Because the X could be here, or it could be here, or it could be here. So you got to be careful when you look for that. Okay. Okay, good.